Welcome back to Algebra 2. Today we're going to do 3.3a, which is talking about factoring. So we're going to use a bunch of different techniques for factoring today. You've seen these before, but we're going to revisit them, show you them again, because they are really going to be something that you're going to have to continue to remember and continue to use. So the first two we're going to talk about is the difference of squares. So if I have x squared minus a squared, okay, so two terms that are squared, and there's a subtraction sign between them, then my answer for my factoring problem is just x plus a times x minus a. We also just recently learned sum of squares. So that's where I have two squared terms with a plus sign between them. And that just changes it so it's an imaginary number. So it's still x plus a and x minus a, but the a has an imaginary next to it. So let's go on ahead and let's look at this first problem. So here, my x squared, okay, it's a perfect square, okay, because if I take the square root of that, I get x. 100 is a perfect square, and I get 10. So my answer then to the factoring problem would be x minus 10 times x plus 10. And you could write x plus 10 times x minus 10. It doesn't matter the order of these factors as long as you have both of them there. So let's go ahead and take a look at the next one. So 4 is a perfect square, and x squared is a perfect square. So the square root of 4 is 2, and the square root of x squared is x. 49 is a perfect square, and the square root of 49 is 7. So my answer then is 2x minus 7 times 2x plus 7. So the next one, 64 is a perfect square, x squared is a perfect square, and 1 is a perfect square. So the square root of 64 is 8, the square root of x squared is x, and the square root of 1 is 1. So my answer then is going to be 8x minus 1 and 8x plus 1. Now let's look at some sum of squares. We're going to do these the exact same way. Okay, so the square root of x squared is just x, and the square root of 36 is 6. So that's going to be x minus 6, except I'm going to add an I to it, and x plus 6, except I'm going to add an I to it. And these are just shortcuts. You can solve all of these using your square roots, okay? Adding 100 to both sides and taking the square root of both sides, and you get x equals plus or minus 10. Okay, but for right now, we're not solving them. We want to factor them. Okay, so we're not trying to find out what x is yet. We just want the factors. Okay, so now I'm going to take the square root of 25, which is 5, and the square root of x squared, which is x, and the square root of 81, which is 9. So I get 5x, and because there's a plus sign between them, it's going to be minus 9i, and 5x plus 9i. The square root of 121 is 11. The square root of x squared is x. And the square root of 289 is 17. So that's going to be 11x minus 17i times 11x plus 17i. The next polynomial identities we're going to talk about is difference of cubes and sum of cubes. So instead of having an x squared and an a squared, we're going to have an a cubed or an x cubed and an a cubed. Okay. So these formulas are very similar, okay, except the plus and minuses are changed. Okay, so the way I like to remember it is if it's a minus, then it equals a minus, a plus, and a plus. If there's a plus between them in the beginning, then it equals a plus, a minus, and a plus. Okay, so these two signs are always the same. And the last sign is always a plus. Just that middle sign that's on that middle term here that changes. Okay. go ahead and see how a couple of these work. So the first thing I'm going to look for is, I see that this is a perfect cube and 64 is a perfect cube. You're going to want to know some of your cubes, and you're going to want to make sure that you have a list of, 1 through 5 or 6 at least memorized. Okay. So the first thing I'm going to do is I'm going to take the cube root of both of these. So x cubed, if I take the cube root, is x. 64, if I take the cube root of that, it's 4. In other words, that means 4 times 4 times 4 is 64. So now I'm just going to plug it into the formula. So since it's a plus, it's going to be just those two numbers I just got with a plus between them, okay, because that's going to be a plus, okay, and then a minus and a plus. Then it's going to be my first term squared minus my two terms multiplied together plus my second term squared. And that's it. That is my answer. So all we're doing is plugging some numbers into a formula, but you have to have this formula memorized, both of these. Okay, so the next one here is 8x cubed minus 27. So 8 is a perfect cube. The cube root of 8 is 2. 2 times 2 times 2 is 8. X cubed, if I take the cube root of that, is x. And 27, the cube root of that, is 3. There's a minus sign between them. So I know my signs in my answer are going to be minus, plus, plus. So I have 2x minus 3. It's just my two numbers subtracted from each other. And then I have 2x squared. Okay, so 2x squared. So 2 squared is 4. And x squared is x squared. So that's going to be 4x squared plus, I'm going to multiply these two together. 2x times 3 is 6x. And then I'm going to add my second term squared. So 3 squared is 9. And that's my final answer. The next one, I have 5x to the 4th plus 40x. Well, looking at this, it's not perfect squares and it's not perfect cubes, but I need to find a greatest common factor first, and then I'll be able to do something with it. So the first thing I see is a 5 and a 40. I can divide both of those by 5. And I have an x to the 4th and an x, so I can divide both of those by x. So I'm going to get 5x, and then I'm going to be left with x to the 3rd plus 9. So now this part right here is a perfect square trinomial. So x to the 3rd, the cube root of that is x, and the cube root of 9 is 3. So now I'm going to have x plus 3. I'm just following my formula. X squared minus 3x plus 9. But I can't forget that 5x I pulled out at the beginning. So that is my final factored form. So let's go ahead and take a look at this next one. So 2x to the 5th and 16x squared. Just looking at it, there's nothing I can do right now. So I'm going to pull out a greatest common factor. 2 and 16 are both divisible by 2. And x to the 5th and x squared, I can pull an x squared out of both of those. So if I pull a 2x squared out, then I'm left with x to the 3rd minus 8. These are both perfect cubes. Cube root of x to the 3rd is x. Cube root of 8 is 2. So now I'm just going to follow my formula. And I get x minus 2 times x squared plus 2x plus 4. And I can't forget that 2x squared that I pulled out at the beginning, because that is still part of the answer. So those four things we just did, difference of squares, sum of squares, difference of cubes, and sum of cubes, are memorizing formulas. The next thing we're going to do is factor by grouping. So we've actually been doing factor by grouping for a while now, when we've been factoring trinomials. So when we factor trinomials, first thing we do is we put things into, we break it up so that there's 4 different terms. Okay? So here we have 4 different terms. So anytime you have 4 terms, you can look to factor by grouping first. Okay? That would be the first method I would always try. So here I can group those 2, and I can group those 2. So now x to the 3rd and 3x squared, I can take an x squared out of both of those. So if I take an x squared out, I'm left with x plus 3. My second group, I can take a positive 4 out or a negative 4 out. If I take a positive 4 out, I get negative x plus or minus 3. But my whole goal in grouping is to get these 2 to look exactly alike. So if I divide by negative 4, then I get negative 4 divided by negative 4x divided by negative 4. And that leaves me with just a positive x. And negative 12 divided by negative 12, or negative 4, sorry, is positive 3. Now those 2 match. So now what happens is we can take this out and it becomes one of our factors. And the 2 things on the outside become the other factor. The reason for that is that now you're actually taking an x plus 3 out of both of these, and you're left with x squared minus 4. Okay, but if you can just remember that these 2 that match is one of your factors, and the terms on the outside form your other factor, then you'll get it. But we're still not done, because now we have an x squared minus 4. So that breaks down to x minus 2 times x plus 2. And then we have that x plus 3. Okay, so whenever we factor, we want to make sure we've factored completely. In other words, that we can't factor by any other methods. Let's go ahead and look at our next one. So there's 4 terms, so I'm going to try factor by grouping. So out of these first 2 terms, I can take an x squared. So I have x squared, and I'm left with x minus 1. Out of this other group, I can take a negative 25, and I'm left with x minus 1. So now I have a matching pair, and I have what's outside of them. So those are my 2 factors, but I'm not done yet, because this is a perfect square, okay? A difference of perfect squares. So taking the square root of x squared, I get x. Square root of 25 is 5, so that's going to be x minus 5 times x plus 5. And then that x minus 1, I can't do anything else with. So that's my final answer. All right, this last one, I have 4 terms, so I can group them. I can take an x squared out of the first set. So I have an x squared, and I'm left with x minus 2. I can take a negative 9 out of the second group, and I'm left with x minus 2. So now I have my pair that match, and I have my x squared minus 9. So x squared minus 9 is a difference of squares, which means that breaks down to x minus 3 times x plus 3. And then I still have that x minus 2 that I can't do anything with. Okay, so the most important thing is make sure you can't factor these things anymore. Okay. The very last thing we're going to talk about today is using polynomial identities for factoring. So now we're going to have some quartics that we're going to factor. So these look really similar to the quadratics we've been factoring. Okay, so our quadratics are x squared, and then, so it's an ax squared plus a bx plus a c. Our only difference here is this is to the fourth, and now this is squared. We're going to use the exact same methods. So the first thing, we're going to multiply our a times our c, and we get negative 24x to the fourth. So when we multiply that, now we have to find our factors that equal negative 24x squared. So 1 times negative 24, negative 1 times 24, 2 times negative 12, negative 2 times 12, 3 times negative 8, negative 3 times positive 8, 4 times negative 6, or negative 4 times positive 6. So those are all my factors. And because this is an x to the fourth, these are going to have to be x squareds multiplied together. Okay? So when we do this, so just like I did with a quadratic, now I'm going to have to find my pair that adds to 2x squared. So the pair that adds to 2x squared is negative 4x squared and 6x squared. So now I'm going to go on ahead and I'm going to replace that 2x squared with those two terms. So once again, this factoring is exactly like I've been doing before. So I have x to the fourth minus 4x squared plus 6x squared minus 24. Now I've got my four terms and I can do my factor by grouping. Okay, so I can factor by grouping. I can take an x squared out of each of these. So that's going to be x squared, and I'm left with x squared minus 4. I can take a 6 out of these two terms, and I'm left with x squared minus 4. So now this is one of my terms, x squared minus 4, and x squared plus 6 is another term. Now I have put everything together. This is sum of squares. So that's going to be an x plus, oh no, it's not. Ooh, did anyone else catch me? 6 is not a perfect square. So that one's not going to change. That stays x squared plus 6. This one is difference of squares. The square root of x squared is x, and the square root of 4 is 2. So that becomes x minus 2 times x plus 2. And that's my final answer. I didn't leave very much room to do these other two problems. All right, so let's go on ahead and do this next problem here. So I'm going to start the same way. I'm going to multiply my a times c. So I have 5x to the fourth. So now I need to find my factors of that. So I have 1x squared and 5x squared, or I have negative 1x squared and negative 5x squared. It just so happens that that's my pair that adds to negative 6x squared. So now I'm going to replace negative 6x squared with these two terms. So x to the fourth minus 1x squared minus 5x squared plus 5. And remember, it doesn't matter which order you put these back in, as long as they're the two middle terms. Now I can do my factor by grouping because I have 4 terms. So I can pull an x squared out of here, and that leaves me with an x squared minus 1. I can pull a negative 5 out of here, and that leaves me with an x squared minus 1. So my matching terms are factors, and my outside terms. Now I'm going to finish factoring these. X squared, that's a perfect square, but 5 is not, so I can't do anything with that. But x squared factors down to x, and 1 factors down to 1, square roots of them, I'm sorry. So I get x minus 1 and x plus 1. And that's my final answer. The last one, x to the 4th minus 16. So just looking at this, I can see that x to the 4th is a perfect square, and it breaks down to x squared. And 16 is a perfect square, and it breaks down to 4. So now I can break that down to x squared minus 4 times x squared plus 4. But x squared and 4 are both perfect squares. So that's going to become x minus 2 times x plus 2. So I have a difference of squares and I have a sum of squares. So this sum of squares is going to become x plus 2i and x minus 2i. Okay, so once again, I have to factor these 100% completely. So I can't do anything else with them. Okay. So sometimes I'll have to stop right here. Okay. But sometimes I'll be able to take it all the way and do something to everything. Okay, so that is it for 3.3a. Have a great evening and ask questions if you have them.